The plate tectonics theory. The internal structure of the Earth consists of three major layers. These are the crust, the mantle, and the core. Under the crust lies a semi-liquid mantle layer of molten magma which can be divided into the upper mantle and the lower mantle. Together, the upper mantle and the crust are collectively known as the lithosphere. Below the mantle lies the core, which is also divided into the outer core and the inner core. The Earth's lithosphere is divided into many tectonic plates that are different in shape and size but fit tightly together like a jigsaw puzzle. There are 7 large key plates and several smaller plates, and the lands and the oceans lie on top of them. Did you know that all of the continents that we know today once formed a single supercontinent? This supercontinent existed 335 million years ago, and we call it Pangaea. Over millions of years, the tectonic plates which hold the continents moved around, smashing into each other and then pulling apart. This process is called plate tectonics. Within the Earth, there is tremendous heat and pressure, and this drives slow circular movements called convectional currents within the mantle layer. This then causes the plates to move. Different tectonic plates meet each other at their boundaries, which are known as plate margins. There are 3 types of plate margins depending on what kind of movement occurs between the 2 interacting plates. These are constructive plate margins, destructive plate margins, and conservative plate margins. At a constructive or divergent plate margin, 2 plates move away from each other. This movement forms a gap between plates, which allows magma to seep through and cool, forming new geological features such as volcanoes. The mid-Atlantic ridge under the Atlantic Ocean is an example of a constructive plate margin. At a destructive or convergent plate margin, 2 plates move towards each other. This can either cause one plate to go under and the other to be pushed up, or 2 plates to smash together and push upwards. This process forms fault mountains and deep trenches and often creates powerful earthquakes. This is how the Himalayas in Nepal, home of Earth's highest mountain, Mount Everest, were formed. At the conservative or transform plate margin, 2 plates slide against each other either in different directions or in the same direction at different speeds. The movements of these plates also cause earthquakes. The San Andreas Fault in California is an example of a conservative plate margin.